I'm Anil Kumar. Let me thank all the viewers for sharing their questions. Now we'll work on the solution of question number 2. So this is one of the question from one of our subscribers, right? So we'll see the solution of question number 2 now. A bicycle has wheels with diameter 60 centimeters. The bicycle moves along the road at a speed of 6 meters per second. The outside of the tire has a speck of paint on it. Determine an equation for the height h meters of the speck above the road as a function of time t seconds. Assume the speck is at the lowest point h equals to 0 when t equals to 0. What is the height of the speck of paint when the bicycle has traveled 55 meters? You can always pause the video, answer the question, and then look into my suggestions. So let's try to sketch the scenario. Let's say that's the wheel we are talking about. We are given that the diameter of the wheel is 60 centimeters. Right, so that is the center of the wheel. So 60 centimeter diameter means that the amplitude is 0.3 and 0.3, right? So that is the radius, correct? So we know that the diameter is 60 centimeter, which means radius is 30 centimeter, or we can say radius is 0.3 meters. So it's kind of important to convert the units to meters, since we have speed in meters per second, right? Okay. We are also given here that we need to find the movement of this speck, right, which is right at the bottom at t equals to 0. So as it moves, then the speck will move upwards. So here the time is moving, right? So what we get here is a function which is going to be kind of like this. You understand, right? So that is how we are going to get our wave, where this is along a road, right? Let's try to understand. So it is along a road, kind of like this, correct? So that is one particular wave, one complete cycle. We need to write equation of this cycle. Perfect? Okay. Now, how do we get that? Okay. Now, let's also understand that one rotation means, because this whole distance is how much? That is what we are interested in figuring out. Now, this one cycle means circumference. So from here, the distance is from 0. This distance should be equal to circumference, right? So this distance, which we will see, let's call this as S. The distance traveled will be 2 pi r, right? 2 pi times radius, which is 0.3 in meters, correct? So this distance or displacement horizontally along the road will be 0.6 pi meters. Is that correct, right? So that is the distance. Now that is one cycle, right? So this is distance for one cycle. So this is one cycle. Basically will take this point through one full circle, right? And horizontally on the road, the car or the bicycle in this case will travel a distance of 0.6 pi meters. Clear? Now what we need to find is one cycle time. We have to find time for one cycle, right? So how can we find that time? Now clearly the speed is given to us as 6 meters per second. We need to find time for 0.6 pi meters, correct? So time, which is the time period, for 6 meters is 1 second, right? So for this much, it is going to be 1 divided by 6. That is the distance, and this is the velocity. So we'll divide the distance, which is 0.6 pi, by the velocity, right? So distance divided by time. So you should know distance divided by speed is time taken, correct? So distance traveled is 0.6 meters and the speed is 6 meters per second, right? So that much meters, the speed is 6 meters per second. So we get time in seconds as 0.1 pi second. Is that clear to you? So that becomes a time period t. Now once you find the time period, then we can actually easily find the equation. Right, so let's find the equation now. Let's say this at any instance of time on the y-axis, we have the height of the spec. So that was the spec, right? So height of the spec, h of t, is going to be, since it is a cosine function starting with the minimum, normally cosine starts with maximum, we'll write this as minus. The amplitude here is 0.3, right? So that is the axis, correct? That is the axis. The amplitude is 0.3. Cos of k, the value of k will be how much? K is, now we can find k here. So time period is 0.1 pi. So k will be equal to t by 2 pi, right? So let's find k before writing this. K is equal to time period by 2 pi. In this case, time period t is 0.1 pi. We are going to divide by 2 pi. So pi and pi cancel. So we get 1 over 20 we can write, right? So 0.1 over 2, better to write as 1 over 20. So that is the value of k. Okay. So we substitute this value of k here, which is 1 over 20, right? So we get 1 over 20 t. Plus this is 0.3 above the ground, the axis, so 0.3. So that becomes the equation, correct? So I hope the equation is absolutely clear. So we have squeezed in all the information in this small area. So at t equals to 0, we'll get minus 3.3 plus 0.3 as 0, so that works, correct? So we have done part A of writing the equation, and in part B, what is the height of the speck of paint when the bicycle has traveled 55 meters? Now, when bicycle travels 55 meters, we have to see what time it takes, correct? So we know time taken will be 55 meters divided by the speed, which is 6 meters per second, right? So that is what we are going to get. So we'll get 55 by 6 seconds. So that is the time. So let's find the height when the time is 55 by 6 seconds. Clear? So we need to substitute that here. So we get minus 0.3 cos of 55 over 6 times 2 is 120, right? So we substitute this value plus 0.3. So let's use the calculator to find this answer. We should set this to radians. That is another important thing whenever you're working. For me, 4 is radians. So now we have 0.3. I'm writing this first. 0.3 minus 0.3 times cos of, within brackets, 55 divided by 120, which we got by multiplying 6 by 20, right? 120, bracket close. So that is what we have, equals to. So we get this as equal to 0.03, right? So that is the height in meters for the given spec when the distance traveled is 55 meters. Correct? So our answer here is that the height above the ground will be 0.03 meters, right? So very close to the ground, correct? So that is how you're going to solve this question. I hope you understand and appreciate it. So let's go through it once again. First, your setting of calculator should be in radians. Now, diameter is 60 centimeter, which is same as 0.6 meters divided by 100, right? So this is equal to 0.6 meters. So the radius or the amplitude in this case would be 0.3. So we get 0.3 here. Since the curve starts with the minimum minus cos function, time period t is calculated by speed, we know is 6 meters per second. Distance traveled in one cycle is 0.6 pi. Dividing 0.6 pi by 6, we get a speed of 0.1 pi. Right? So time period of 1.1 pi for one cycle. Now k is equal to t by 2 pi, and so we calculate the value of k as 1 over 20. So we get the function h of t is minus 0.3 cos 1 over 20t plus 0.3. Substituting, we get our solution as height will be almost 0.03. It will be very close to the ground. So that is how you could answer this question. I hope it helps. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.